record on this computer. All right. A machine used to fill half-gallon size milk containers is regulated so the amount of milk dispensed has a mean of 64 ounces and a standard deviation of 0.11. So now we know the mean here is 64 with a standard deviation of 0.11. All right, now you randomly select 40 containers. So this is a sample. And we pick n equals 40. We pick 40 containers randomly. And we measure the contents. In this case, we came out with the mean, the sample mean. The sample mean of the containers is 64.05. So X bar equals 64.05. So that says, does this machine need to be reset? So this is the question we're trying to answer. I'll do it in purple. That's the question we're trying to answer. Explain your reason. So what we do is we realize that in the case of this one sample, 40 different containers, we realize that the sampling distributions of sample means, if we were able to do them all, will be a mean of 64. So this is mu's of X bar, and I should really make it like obvious where it is. So the mean of the means should be 64, and sigma X bar should be 0.11 divided by the and that looks awful now. So let me go back to the previous one. 0.11 divided by the square root of the sample size. In this case would be 40. And we know that 64.05 is somewhere over here. Now, what we want to see is we want to check out this area here. That's what we want to do in order to check if something is likely or not. And I should really, I don't know why I wrote a 4 there, but this is supposed to be a 5. So what we do is we do our new z-score. It's X bar minus mu divided by sigma divided by the square root of n, which essentially is 64.05 divided by 0.11 divided by the square root of 40. A lot of you have issues with putting this in your calculator. If so, then make sure you do it numerator and denominator separately. I'm gonna go ahead and take my numerator, 64.05 divided by parentheses 0.11 divided by the square root of 40. And I get a ridiculous number that I'm not so sure is true. 1 second. I forgot to put minus 64 here. So it's 0.05 divided by parentheses 0.11 divided by the square root of 40. So now I'm supposed to get a decent number. So I'm gonna go ahead and do this to 2 decimal places. I get 2.87. Make sure you check that you get that. Oops. So now this models the following. This models the following. It says, you know, this is equivalent to a z-score of 2.87, which is probably out here somewhere, but you know, whatever, not to scale. And you want to find out this area. All right, so let's do it. What do we need to do to find that area? We need a table. Let me see if I get my table here. You should have your tables out. And I have my table here. Huh? So if we go to our table, 2.87, it gives me 0.9979. So this area here to the left is point, I can't believe I forgot those numbers, 2.87, 0.9979. So we take 1 minus 0.9979 to find that area. So 1 minus 0.9979, that's 0.0021. Now, what you need to realize here is that this measurement here, 64.05, is 2 standard deviations, more than 2 standard deviations away from the mean. And we've said earlier in the class that if any particular, we said earlier in the class that if you're here, somewhere over here, or you're here, somewhere over here, we would say it's unusual. So we would say that the measurement of 64.05 is too far away from the mean to be purely by chance. I mean, there is a 0.0021 probability of it being there or higher. But when we start crossing that threshold of 2 standard deviations or higher, or negative 2 standard deviations and lower, we start saying, hey, there's something fishy going on around here. It's too far from the center, from the mean, to be by chance alone. I mean, there's still a chance. Okay. But it makes it, good morning. It makes it more uncertain. Is Yada on her way?
I have no idea.
Okay.
She's not here yet.
Okay, thank you. So, I mean, that's in a nutshell, that's one of the responses. So you would probably say something like this, that it's very unlikely that we would have sampled 40 containers with a mean equal to 64.05 ounces. Okay, that's what you would say, something like that. Okay. Questions or concerns? I'll write it here, I guess. I'll write it here, I guess. It's very unlikely that a sample of 40 containers would have a mean of 64.05. Good morning. Good. Okay, there we go. So Shayla's here, Angie is here. Okay, so we're missing just Yada, Anthony, and Seth. It's very unlikely a sample of 4, huh? Okay, so let me show them excuse absence. So it's very unlikely, I feel there's something missing there for unlikely. Is there L and Y at the end? There we go. That a sample 40 containers would have a mean of 64.05 because it is more than or equal to 2 standard deviations from the mean. Got it? So none of your teachers have rebuilt an engine ever before, except Machado maybe? Machado, of course. I haven't met Miss Iglesias. She's rebuilt an engine? Wow. Which is Mrs. Iglesias? She's what? She's a what teacher? And she teaches English? Is she married? I'm married. All right, so yeah, that's really cool. How old is she? Amazing. This is very interesting. Does she use a Surface? Does she use a Surface? All right. Yes.
You wrote there's a -2 and a 2. You're saying that if it's greater than 2.
2 or greater, or -2 or smaller, we say it's unlikely. Yeah, it's too far away from the center. Well, it's unlikely because what happens is we say anything that's 5% or smaller in terms of area. Well, this also gets later on when we do left and right tail test, but for now, if it's 2 standard deviations or further away, or -2 standard deviation or further in the other direction away, and we start considering it to be unlikely. Like, that's not usual. All right. So I'll go ahead and now we're going to do number 37. And then I'll give you 2 questions to work on, and that'll be your classwork today. I'll put the answers on Teams, and I expect you have enough time to get it done within class and turn it into me for a grade today. And those of you who want, by the way, this 9 weeks, you know, your grades are going to be what they're going to be. Everybody's passed my class, so I'm not going to feel horrible about. Everybody's passing. Nobody seniors gonna be left behind. Everything's great. Everything's all wonderful. Did I? I can't remember. Did I? Find out. Look at your grades. All right. I can't remember though. I might have, but I can't remember. I don't want to give you false hopes. All right. Says there, number 37, a manufacturer claims that the lifespan of its tires is 50,000 miles. So this is the claim right here. You work for a consumer protection agency and you're testing this manufacturer's tires. Assume the lifespans of the tires are normally distributed. So here's what you got so far. The mean that's claimed by the manufacturer, let me make this mean at least 50,000 miles. Yes or no? Oh, did I get it? Oh, and then it's saying now that the original distribution is normally distributed. Now, if we go back to central limit theorem, there was 2 parts. One part said we have a distribution. If we pick sample sizes of at least 30, then the resulting sampling distribution is approximately normal with a mean that's equivalent to the population mean, and the standard deviation is equal to the population standard deviation divided by the square root of n. In that case, n had to be at least 30. Now, this is assuming we're able to pick every single possible sample of size 40 possible. However, there's a second part that says the original distribution was already normal to begin with. Any size n would do, and the resulting distribution wouldn't be approximately normal. It would actually be normal. So there's a slight distinction we're making between a sampling distribution of sample means that's normal versus approximately normal. And the only way we can have a sampling distribution of sample means that is normal is if the original distribution was already normal to begin with, the original population. In this case, we're guaranteed that because the original population is normal, as told there. Let's say it says it right there. Boom, boom. Now we take a sample. Our sample here, I really should do that nicely. Our sample here is n equals to 100. And the mean that we got from that particular sample was an X bar of 49,721 miles. Now we gotta assume that sigma is 800 miles, so we can write up here that sigma is 800. This has to do with the population. Remember, all this here is population. And I really should write that nicely. I'll do it over here. This is the population. So it says here, part A, I'll do this in purple. It says, assuming the manufacturer's claim is correct, what is the probability the mean of the sample is 49,721 miles or less? So what is the probability that the mean of the sample is 49,721 miles or less? So that's less than or equal to. That's less than or equal to. So this is the question we're trying to answer. Wow, sneeze twice. Let me zoom out a little bit up here. All right, here we go. So let's do it. So obviously the resulting distribution, a sampling distribution of sample means should, in theory, have a mean of X bar of 50,000. And it should have a sigma X bar of 800 divided by the square root of 100. That's ideally what it would be. Now, this particular measurement was 49,721. It's not a measurement itself. It's a mean. So we got the mean. And we want less than or equal to. So that's going to be this area here shaded. So we say Z equals X minus X bar minus mu's of X bar divided by sigma X bar, which is really X bar minus mu divided by sigma all over the square root of N. So we have that this is 49,721 minus 50,000 divided by 800 divided by the square root of 100. So we're going to go ahead and carry that out. 49,721 minus 50,000. And then we're going to divide that by parentheses 800 divided by the square root of 100, which is 10, but whatever. Let's go with the flow. And we get that this particular z-score is approximately 3.49. And remember, that essentially models for everybody this situation here. So that models by a standard normal distribution with a z-score of 3.49. Remember, these are z's, these are X bars. This is a z, this area here. And we looked that up. It comes out to 0.0002. Obviously, this is really far out there. Again, when we get answers this far out, we start being suspicious because it's not within 2 standard deviations from the mean. It's actually negative 3.49. Okay. So we would say here that the probability, the answer to this here, the probability to this is 0.0002. And we're pretty much done with that part of the question. I'll wait because some people are writing. So she has a Fox body. What year? What color? I sold my Fox body.
Well, I think it was red. I think it was red. Year cover.
Okay.